Hello, this is Tim Baldridge. Yeah, a little bit of a different video today. I had some props I wanted to use today, so I decided we'd do a video, movie with the webcam instead, and we take a look at some props. So this is something that's been on my mind a lot lately, and I want to use some props to demonstrate a certain concept, a way I see us thinking about programming and programming languages in general. And so let me get my first prop. We're going to start today by looking at a guitar. Now, there's some interesting aspects about this guitar and all guitars in general. And we're going to contrast this instrument with some other instruments. Now, stay with me. In a little bit, we will talk about what this has to do with programming and why we should even care. But first of all, I want to notice how there's this nice feature on a guitar. There's these frets, where basically you are only allowed on this instrument to play notes that would make sense. So for instance, if this is the open string, this is not tuned because I'm not actually going to try to play anything today, but if we play the open string, we have this note. If we go up to this fret here, we go up a little higher. And so I'm plucking with my hand, so it's going to sound a little weird. But the idea is that if we know that this string is in tune, no matter where we press down on the frets, the fret, if you can kind of see here, is this little line here, and you press the string down on it, and it makes sure that you have the exact position you need to make the correct pitch. So you're going up in half steps here. And it's that way with the other notes as well. So that's kind of nice, that your finger can be anywhere from here to here on the neck, and the tone of the sound may change a little bit, but in general, from here to here, it's going to be the same note. It's the same note, which means I don't really have to worry about where my fingers are, right? It's a really nice feature of the guitar. Second of all, up here, we have these screws. Now these screws are used to tune the instrument. You turn them and it tightens the string and loosens the string, right? Now, I don't want to insult anyone's intelligence here, but I'm not sure how much people know about music, so sorry if I'm being a little basic. But one thing to notice is the way these tuning knobs are created. Basically inside here, you can't see it, but inside here, and sometimes it's open on some guitars, you'll see a worm screw connected to a gear. So the gear turns the pin, and then there's a worm gear or a screw that when you turn this, it turns the gear. Now, the great thing about this is that those worm gears cannot turn backwards. In other words, there's a lot of pressure on this peg right now, but it's not going to turn the knob here backwards, right? It can't because of the way that the worm gears work. So it's really kind of nice in that you can kind of tune exactly where you need it to be, and it's going to stay there. And that's a nice feature in an instrument to have. Yeah, hey, it'd be nice if it would stay tuned. The other thing I wanted to notice is we have 6 strings, and they're all flat, right? So we can kind of play 6 strings in general. This is horribly out of tune. But we can play 6 strings at once and kind of get a chord, right? So we could play chords with this thing. We could play single strings. We could play multiple strings. Those are all lots of nice features, the nice things to have, and kind of, as a musician, makes it more comfortable to pick up and be able to play a variety of music. The other thing that's great about this is because of these frets, it's very newbie friendly, if you will, right? Anyone can sit down and say, hey, I could sit down right now and figure out some positions, and I could play Mary Had a Little Lamb in a matter of a few minutes. So that's a guitar. Now, I want to contrast that with one of what might be the worst designed instruments you will encounter. I'm going to be very careful with this because this is not mine, it's my wife's, and she'll be very irritated if something happens to it. But this is a violin. Now, a violin, if we're going to contrast this with a guitar, there's a lot of things about this that are just badly designed. First of all, there's no frets, right? So, And picking with it is very hard. You have to use this bow, which is another strange thing. So you're going to run two strings against each other and make a sound. But more importantly, there's no frets, so I don't know where to put my fingers. I'm going to have to memorize where to put my fingers on the neck of this. That's not very newbie friendly at all. Second of all, you'll notice we don't have those the worm screws that we had on the guitar. In fact, all these are wooden pegs in a wooden hole, which means that over time they will loosen up and you can kind of damage the wood if you keep stress on them a long time. So when you're done using the instrument, you really should detune these, which means every time you want to use a violin, you have to retune the violin. Yeah, that's not optimal. What's another thing about this? Oh, the other thing is, because of that friction, what you actually have to do if you want to tune the violin up, you want to increase the pitch, you have to detune the string in order to retune it. So you actually, if you want to go higher, you want to tighten it, you need to loosen it and then tighten it. And that has to do with the way the friction works on these pegs. So they're just pegs in a wooden hole. And so it's all based on friction instead of any sort of, gears or that sort of thing. Also, if we look here, we'll notice that the bridge is curved. Right? And this curving means that I can't easily play any sort of chord. In fact, I can't even pluck this at all. I have to use a bow. Let me see if I can get the bow out here. And the bow itself is basically hair that, and this is not tightened, but before we would use it, we would turn this and it would tighten up the hair. Now, in order for it to even to make the correct sound, we also have to put this rosin on the bow. It's sort of a, actually I'm not sure what it is. It's some sort of weird substance you put on the bow. So let's contrast these two instruments a little bit, right? The violin is very musician hostile, shall we say, right? Why would anyone ever play a violin where you have a bow that you have to rub against another string? And if you have ever heard a new violinist play, you will understand that the sound of a beginner violinist is one of the worst things you will encounter. It's screeching, it's scratching, it's horrible sound. And you compare that to anyone can pick up a guitar and start plucking some strings and make some music, right? Because you have that bow, you have to have the curvature in the bridge, right? Because you have the bow, in order to be able to make it so you can play a single note, that's why we have this curved bridge. So we'll take the bow here to play one string and down here to play another. And that whole concept of switching back and forth as you play the bow across the strings requires skill, the right angle of attack, so you only play, one note instead of two. And if you want to play a chord, you can't really. Some experts get close, though. You kind of do this motion to play all the notes together. So why would anyone use a violin? First of all, what's wrong with people that they haven't updated a violin to be better, like the guitar? Well, one of the first reasons is because it would change the tone of the sound. If you were to go to that violin and you were to replace the wooden pegs with, for instance, those screws from the guitar, the sound of the violin would drastically change, right? If you started plucking the strings, which some musicians do, some musical pieces call for plucking the violin strings. If you were to do that, the sound of the violin would change drastically once again. The frets. Without the frets, an expert can actually slightly detune the sound of their violin. They go up a little bit, down a little bit, or even slide from one position to another. There's a lot of different things that can be done, and all that kind of comes together to make the violin a very unique instrument. But like I said, there's a price you pay for that power, that flexibility in the violin. You pay for mostly up front when you're learning the instrument. And that a new person who has never played a violin or a guitar is going to pick up the guitar much easier than the violin. And so let's bring this to programming. What am I even talking about here? I mean, I'm not going to try to make any sort of weird analogies between, frets and static typing. I mean, that'd be fun, but it's kind of a stupid analogy. What I am primarily focused on here is why is it that I find myself in discussions with developers being so unconcerned about developer happiness? Now, some languages are built upon this, but I took a step back and realized that in my childhood, I come from a very musical family. I'm the least musical of a family of 7. Almost everyone else in my family plays piano exceptionally well. Some, have won state competitions and stuff. And I'm the least musical, but I know how to carry a tune. But in my life growing up, I kind of always had this idea in the back of my head that if you want to be good at something, it takes time and it takes practice. That you can't just sit down and say, I'm going to learn a guitar today, and by tomorrow I'll be playing a song. Maybe a couple months of studying an hour every day on a guitar is going to get you to the point where you're going to be good enough to maybe, strum along to a tune. And with a violin, it's much longer. I think when my siblings and parents have started to learn violas or violins, it's been somewhere around 2 or 3 years, going from horrible screeching, scratching sounds in the bed, and when they're practicing in the bedroom, to actually making something that sounds okay 3 years later. And even then, there's times when people who have been playing these instruments for 5 years will play a tune and you'll hear a little scratch or something there. But there's that amazingness when you encounter a concert musician who can play a violin, and they've been practicing for 15, 20 years, and it's phenomenal. And you realize that sound could not be produced by any other instrument. And that there's a reason that the design of the violin hasn't changed in hundreds of years. Now, I'm not going to say Clojure or any programming language is, going to stand the test of 100 years. But I think it's an important point. And that is, a lot of times, things that give you more power, more flexibility, require more practice and more thought. They require you to understand the trade-offs. They require you to think more about why you're doing something a certain way. If all you want to do is just sit down and make some music, then go play an MP3 on your computer. That's automated. If all you want to do is just pick up the simplest way to make a sound, a piano. There's nothing wrong with a piano. You can just hit the notes and all the notes are laid out there. It's great. But something as amazing as a violin comes only with a lot of practice and a lot of work. And as an example of that, I would recommend to anyone, and I'll try to put a link in the description here, go listen to a rendition of Scheherazade. I remember the first time I heard that song, and there's a violin solo, specifically the violin solo in that song, I was moved to tears, and I don't even know what the song is about. But there's something about that violin is so beautiful that it moves you, the emotion, it's incredible. And so that's why when I'm in discussions with developers and I hear such and such is developer unfriendly or developer hostile or this is not developer friendly, I have a hard time caring. Not because I'm not concerned about the rough edges of something, right? I mean, if we were to take this violin or the guitar and we were to, replace the strings with bandsaw blades, obviously that's not a good idea. But a lot of times, these rough edges in languages, especially in Clojure, are trade-offs of some sort of reason, right? The stack traces are the way they are because it's hosted on Java and on the JVM platform, and there's, each one of those methods are a specific size to enhance inlining and all this other sort of stuff. So it's one of those things where you're getting better performance and trading off perhaps the size of the stack traces or the ability of the runtime to say, here's exactly what you need to change here. And some of those things just take time. They take time to learn what a specific stack trace means. Saying int cannot be casted to IFN is hard for a new user to understand. I will admit that. But it's something you learn. after the second or third time debugging that, you realize, oh, there is a place where I'm calling what I think is a function and I'm getting an integer. Maybe I should start in that code I just wrote and see what function calls could be integers. So that's the video I had today. I wanted to compare and contrast these two instruments that are very, very similar. In fact, I almost should have brought out a mandolin. I have a mandolin that is the same tuning, same setup. It's almost exactly the same as a violin, except it's strummed and plucked like a guitar. But the tunings are the same, the strings are the same, and it's easier to play. I mean, that's why I picked it up originally, is I could sit down and just kind of strum along. So yeah, that's the video I had for today. I probably won't do too many of these sort of videos because, hey, who wants to look at this when you can look at code, right? But something to think about is to think about, if something I am learning is hard, is it worth it? What's the payoff? Can I invest a little bit of time now and become just that much more productive tomorrow, or a year from now? Someone asked me recently, how much experience do I need to have in Clojure? I mean, I get this question all the time. How much experience do I need to have in Clojure to get a job? And I don't have a good answer for that. A lot of it is how proficient are you? Can you write an application? And that sort of thing. But from my personal experience, I spent about 2 years of my life learning Clojure and programming in my spare time before I got to the point where I could be hired. Now, that's a big thing to ask in this day and age. I'll admit, technology changes, technology moves, and it's hard to pinpoint, yeah, I want my career to be here. For me, that's a decision I had to make at one point, was that I was programming in .NET and C#, and I said, I hate this, I want to get out. What language would make me happy? And at the time, Clojure was the only functional, dynamically typed language that was fast. I always like performance stuff, right? It worked on the JVM, and the JVM's everywhere, and it, Clojure values immutable data like almost no other platform, and that was it for me. And so I decided this is a route I was going to go down to, and I studied for 2 years. And I have to say, sometimes, with all honesty, sometimes I think we just need more of that in the tech industry. If something is very powerful, if you believe a piece of technology is very powerful, maybe 2 years isn't too long of a time. I don't even know why I'm hesitating about this, and that's the fascinating thing to me, is what's wrong with saying spend 2 years of your life to learn a piece of technology? And I'm throwing that number up there. I mean, by all means, try to get a job in Clojure before 2 years, especially if you're picking it up quicker. But we see this in almost every other industry. We see, like I said, a lot of musicians in my family, a lot of them practiced for 10 years, a decade before kind of being ready to maybe get a job in some symphony somewhere, and they were good at what they did. I look at other areas. I have family and friends who are engineers, electrical engineers, mechanical engineers. All these people have studied for 4 years in college, perhaps, to understand all the concepts behind these things. Law would be another one. I have a friend who's a lawyer, and it's the same sort of thing. They study for 4 years, and then they're almost hireable, right? And it's like, you still got to find that one company who's willing to take a risk on somebody that just got out of college. And I think we've lost that in the tech world. I think mostly because it's so easy to pick up, and languages are so much the same in a lot of ways. I think I picked up C# in 3 weeks or something like that, because it's so similar to Java and all the other languages I had learned. But for something as different as Clojure, really any functional language, I did some work for a while with Erlang, and it was the same sort of thing, was that I realized it would take me years to understand OTP and the whole platform behind Erlang. And I didn't want to spend that time. I didn't want to spend that effort to learn it. Whatever reasons aside. But I realized with some of these platforms, and I mean, any of the big functional languages are going to be this way. Clojure, Haskell, Erlang, F sharp, maybe to some extent. These languages are different enough from the main platform, so you can take more than 3 weeks to learn, 3 months. I reject this whole idea of 6 months I can be down out the door and hireable. There's more to languages than just that. Learning the ins and outs, learning the best practices, learning all these things. So all that to say, don't be afraid. Don't be afraid to continue learning Clojure. Take it slow, absorb what you can, learn what you can. And if the language is really as good as I believe it is, as many people believe it is, it's worth that time. It's worth taking the time to learn. And it's worth taking the time to expand your mind and to learn about new concepts. So that's all I had for today. Thank you for letting me rant a little bit, and some points to ponder. Thank you.